quiz. So, okay, recording is up and running. Let's go through our announcements. Ed puzzles, ed puzzles, ed puzzles. We have some due tomorrow. We have old ed puzzles, continue to complete those, and new ed puzzles. So just ed puzzles. But yeah, keep working on those. You're doing a great job. I was grading them pretty much right up until I started this session, and I will continue to do so throughout the remainder of today and tomorrow. So please continue to do those. Again, scores are looking great. Participation and efforts looking great. Actually, really stoked on how hard y'all are working. So my hat's off. Shout out to y'all who are doing those and working hard on them. So keep doing them. They look good. The remote learning agenda, that's our pacing guide. Continue to use it. If you're not sure what I'm talking about, I know I mentioned it basically every class, but there's a little review of what it is. You see today we're learning lesson 14, which is on factoring. Yeah, continue to use this to your full advantage and continue to fill out those RLQs, the remote learning questionnaires. Those are those Google forms that some of y'all have been really taking advantage of and asking questions on. Looking great. Haven't gotten really any this week, but if you do have any questions, as always, never hesitate to fill one out. Email me directly, or as usual, if you're here right now live in the session, ask me. So cool. Big one, number 3, PowerPoint notes posted. Those are new notes that I'm making accessible to you. These are not from our direct textbook. As a matter of fact, they're from a previous school that I taught at. We were using a different textbook for teaching Algebra 1. And as you can imagine, despite the textbooks being different, the material's still the same. So the notes are very conducive, easy to follow through and understand. So real quick, before we go any further, I want to talk about where you can find those notes. Okay, so right now I'm just on period 4's Google Classroom, but it's going to look the same. I pretty much post everything to all the classes at once. There's how y'all got in right now. There's the link. You know that, obviously. You saw it earlier today. There's a new ed puzzle, which some of you already been doing. All you got to do is watch the video. No questions on that one. It introduces our topic for today, factoring, factorizing. That post right there says good afternoon class. You might have seen it. It's just kind of a completely unrelated to math post on the wellness website that Miss Desso was integral in getting up and running, and also just a little recipe that's an extension to the eating healthy video that I believe ASB might have posted. I don't know, but again, that's all completely separate of math. If you want to check it out, feel free to do so, which takes me to what I actually went to our classroom, which was to show you the notes that I posted. Okay, so both here on the stream, it's a little bit down, and if you were to go to the classwork in module 4, because that's where we're at now, if you see this little resource right here at the top of module 4 that says quadratics bundle, 6 attachments, there's a lot going on in there. The summaries, the vocab word summaries are basically the lesson summaries at the end of each unit, at the end of each lesson. We have the assignment sheet, we have the parts of a parabola. The student text near the bottom is basically the textbook that I've made available to you via PDF form if you don't have it accessible to you. And then those bottom 2 yellowish looking links are the notes. Okay, so again, I want to focus on chapter 8 right now because we haven't gotten chapter 9, but chapter 8, quadratic expressions and equations, that's what I'm referring to when I say check out the new notes posted. We are actually going to use those together today in class, so you'll get a first-hand glimpse as to how maybe useful they can be or what they are all about. So last but not least, extra Zoom session. We have our Zoom sessions. It's not really extra anymore. Just kind of copied and pasted last week's announcements, but we have another Zoom session for our office hours tomorrow, Friday at 10 a.m. Hopefully I'll see all y'all there. If you're not there, again, it's not mandatory. Don't stress it. It's basically there for you to come in, ask questions, get some more insight, get some more practice with me leading the discussion. Or if none of the above really matters, then you can come in and say what's up, and we can talk while 10 to 11 a.m. kind of goes by. Okay, so that's what that's open for. Hopefully I'll see you there. Last but not least, 4th quarter progress report grades due by Monday at noon. Get your work in. A lot of you have done a really good job on that. I just want to continue to encourage that high level of work and hard work that you've been putting in. I'm very grateful for the work that you've been doing. It's been awesome. You guys are really stepping up to the plate and kind of crushing this remote learning thing, which is a testament to your abilities. So awesome. All right, so we did zero product property on Tuesday. Today we're going to talk about factoring. Factoring. We're going to we're going to do so by defining certain words and actually visiting a whole nother separate PowerPoint. I'm going to start off by going to pages 501 and 502, and that's going to be where we check out the vocab, and we're going to learn how to factor polynomials, which will be super useful when it comes to solving these second power functions as we progress through the end of April to May. Sweet. Okay. Let's do this. Okay, so I'm on page 501. We are actually about to delve into lesson 14 today and Tuesday. This will be at minimum a 2-day lesson on lesson 14. But I want to actually jump back to lesson 13. Although we're not doing that in class, one of the words, key vocab words in lesson 13 is integral to us understanding the concepts. So let's see. Try to limit the noise right now. If you need to talk, unmute yourselves, okay? But I'm going to mute y'all just because it was some weird background noise. Okay, so again, unmute yourself if you have GCF, acronym for greatest common factor. We've seen these in previous math classes, like, hey, what's the greatest common factor between 8 and 12? We would say, all right, the greatest common factor, using little factor trees, is 4. We can divide both 8 and 12 by 4. And then we applied this logic both in past and current math classes when we were starting to simplify fractions. Say, all right, since can be divided by 4, we can divide by 4 over 4 and simplify the fraction. So we've used factors extensively in previous math classes to get to where we're at now. But now we're going to use the same idea of a GCF and greatest common factors combined with something that I'm going to call to really help us and understand and have the ability to factor and simplify down extremely or seemingly more extremely difficult polynomials. So GCFs, the highest number or the highest term have variables starting in the mix, we can also factor out variables. And that's what we're going to kind of use to integrate or understand today's lesson. As I cruise down numbers or values or expressions that we can use to multiply to get something else, like we said, factors of 8 could be 4 and 2 and 1 and 8. Factors of 12 could be 4 and 3. So we're going to use those ideas of factors here in a second, which really takes us to the main method that we're going to be talking about today. It's called the X method. And the X method is simply just an organizational tool. It's basically to show the products and sums of numbers, okay? Products being multiplication, sums being addition. We're going to talk about the X method in just 1 second. I just wanted you to introduce to the fact that what we'll be doing with our knowledge of factors in the near future here. All right. So what you're about to see are these new notes that I alluded to at the beginning of class, the ones that I posted yesterday and that are available via that quadratics bundle in your Google Classroom. Feel free to check them out, okay? But here you go. We're going to start on slide 26. You could take notes on a separate sheet of paper, or you could just follow along. Remember, you have these notes accessible to you. So here we go. The main thing that we're going to see today, and what I want to start off with nice and slow, is what it means to factor something, the inverse of the distributive property. So in previous math classes, we learned how to factor numbers. Like you can see factors of 6 being 1 times 6, 2 times 3, all these numbers that you see in green to the right of factors of 6 are actually factors of 6. And then you can see as the number gets bigger, the potential for more factors like 120 having all of those numbers runs into the mix. Now, we can also factor in values that involve variables, where now we're throwing x's and y's into the mix, but they're still factorable. So, boom. For GCF, what we're really doing is we're doing the inverse or the opposite of the distributive property, and we're going to see that. If my PowerPoint wants to work, we're going to see that right there. Okay, cool. So if I was to say, hey, factor the polynomial 15x plus 25x squared, what we're looking for is GCFs. We can take out numbers from both 15 and 25. We could take out 5, and we could take out the variable x from both of those. So effectively what we're doing today is the exact reverse or the exact opposite of what we did all last week. Instead of distributing 5x times 3 and 5x times 5x, we're learning how to take out factors. And then we can also factor by grouping. And you can see here in the bottom of the slide that the factoring by grouping makes two groups of two, shown in the red parentheses, because not everything has a common factor, so I try to group them up and then pull out GCFs. So what I'm going to do right now is stop on this slide. And if you have a sheet of paper, now might be an awesome time for you to kind of pull it out, because I want to do this little practicing here. Okay? And again, this is not in your textbook. The textbook doesn't really jump into factoring using GCFs, so I kind of wanted to address it in a more standard pencil and paper method. So effectively what I'm asking us to do is a binomial expression. One term 4x plus a second term 8. Notice they're not common terms because one has an x and one does not, so I can't really add these two together any more than just showing the addition problem, the addition expression. But I don't really care about simplifying this. I want to factor it. So I want to factor it by using GCFs. So I guess my first question is, what is the GCF of both 4x and 8? Does anyone think they know that answer? What could I take out of both terms? What could I take out of 4x and 8? And keep in mind, factoring is just division. And I've seen some great answers. Sarah, Tyler, L, 2 is possible. So let's try that. If we said we could take a 2 out of both, well, we would divide both by 2. 4x divided by 2 is 2x. 8 divided by 2 is 4. What y'all just did, by the way, is you just gave me a common factor that if we turn right back around and distributed, get right back to our original value of 4x plus 8. Great call. But I'm going to actually zoom in on Sydney's answer, because Sydney gave us an answer that, like Francis kind of just repeated there, the actual that is the G in GCF, greatest common factor, isn't 2, but it's 4. And here's why. Because you can actually divide both 4x and 8 by 4. The GCF is 4. And here's what happens when we take a 4 out of both. Ready? 4x divided by 4 leaves us with x. And 8 divided by 4, notice my denominator tells me what I'm dividing by, what I'm removing is 2. So if we were to take out that common factor of 4, what we would get left with would be just x and 2. And there's our factored form, okay? And Sarah, I do believe you are right, great call. But when we're looking for factoring, what we're really trying to do, y'all, is we're trying to basically undo the distribution process. If I would straight from the jump, simplify this, 4 times x plus 2, y'all would have been, all right, 4 times x is 4x, 4 times 2 is 8, boom. Multiplication, like you already know how to do so. Like if I said, all right, what's 4 times 5, you would say 20. And then if I said, hey, factor 20, you would tell me factors could be 4 and 5. They're truly like cyclical, meaning they're going back and forth on each other, so to speak. They're inverses, to use the proper math term. So really what we're trying to do today is kind of undo all the distribution that we learned last Tuesday and Thursday. For no reason. It's not just to make your life miserable, but rather to allow us to kind of combine what we talked about on Tuesday, the zero product, to make all things really, really quick and easy. So there's our factored form highlighted in green right here. Boom. Answer to the first one. Sarah has given us her answer to the second one. And the second question was, okay, what is the GCF? And I'll write the GCF in blue here. What's the GCF of 12x and 36? Sarah said 12. Right on. And Francis has actually given us the answer based on that. So he said, all right, the GCF, drop it out in front, extract it, divide it. And when you divide negative 12x by 12, well, the numbers are gone, and what do you have left? You have a negative and an x. So negative 12x divided by 12 is negative x. And when you divide 36 by 12, what do you get? 3. So I'm just going to bring it on up. And to remind myself that it's a positive 3, I'm going to put a plus in between them. Now, the quickest and easiest way to check, and I always love a good checking our work here, is to turn right back around and distribute. What is 12 times negative x? Negative 12x. And what is 12 times positive 3? Positive 36. Sweet. It checks out because look at that. Boom. It's right back to our original expression that we were trying to factor. So that is how we could factor by finding a GCF, a common factor. So do I have any questions on the first two examples, which the examples themselves I'm highlighting in purple, and the answers I'm highlighting in green? Any questions on what it means to factor with a GCF right from the jump? Cool. Okay, so let's cruise on down to my next problem. I want you to factor this red one. How can we do so? Anyway, it's actually going to be kind of a new concept that we can work with, it called grouping too. Francis says he found a GCF of 2. Sweet. So Francis said his GCF, something that he could take out of all 4 terms, because to be common, you have to be able to take it out of everything, is 2. So if he takes a 2 out of everything, here's what he has left. What's 6x divided by 2? 3x. What's 12 divided by 2? 6. What is 2x divided by 2? X. And what's 4 divided by 2? 2. Great call, man. But is that as simple as possible? No. Unfortunately, 8 is a common factor. A great call, Sydney. How did you figure out that 8 is a common factor? Or does anyone know how Sydney said that she thinks the GCF is 8? Because she's totally correct. Yeah, there you go. Combine like terms. So Sydney basically came to the conclusion that she said, well, if I have this, why don't I add up the things that are like the x's and the x's and the numbers and the numbers? Okay. And then she realized she could take an 8 out of both of those things. 8x divided by 8 is just x, and 16 divided by 8 is 2. Sweet. Great call, Sydney. And that is one way to combine or factor expressions. When we have the ability to combine like terms, like we did following my laser point, when we were given an original expression, we combined like terms to get to this purple and blue binomial, 8x plus 6, and then we established that the GCF was 8, voila. There's one other way to do this, and I want to actually kind of zoom in on it here, because this is how we're going to factor polynomials, things with a bunch of x's, okay? Technically speaking, the red one is a polynomial as well, but let's rewrite this problem. 6x plus 12 plus 2x plus 4. And what I'm going to do here is I'm going to make the possibility of factoring by something called factoring by grouping. And the reason why it's called factoring by grouping is because we use grouping symbols, and the most common grouping symbol we use is parentheses. So basically what I'm doing here is I'm going to group things down to make smaller groups. So think about class. When we were in class, we had about 30 to 36 students in any given class. And to have y'all all work out loud in one humongous group would have been chaos and madness. I'm sure we could all kind of picture that. So what did sometimes I do to allow us to write smaller groups? Now, we work in smaller groups because it's easier to work with people when there's less of us. Also, when you group people into smaller groups, there's a much better chance that you have something in common. You all have a common factor for using math terms. So the chance of finding something in common amongst all 4 terms, although Francis did it, so sometimes when we have multiple terms, we can make smaller groups. So all that I've done here is I made 2 groups of 2. Group number 1, group number 2. I'm effectively just reorganizing or revisualizing how to see that. Now, what can I do is I can factor each group individually. What is the GCF of my first group? 6. So I'm going to take it out. And when I take it out, what do I have left? I have, well, 6x divided by 6. Ready? 6x divided by factor 6. Leaves me with just an x on the inside. So all that I'm doing here, everyone, is I am going through and I'm groups and factoring groups. I'll answer that question on homework in just a second. 12, taking the 6. 6 out of 12. 12 divided by 6 is 2. Okay. What is the GCF of my second group? What can I take out of both of those terms? 2. Okay. So I'm going to take a 2 out. And then when I take a 2 out, what do I have left? Well, what is 2x taking out that 2? X. And what is 4 taking out that common factor of 2? 2. Let me clear up all this extra miscellaneous writing. What we now have here, y'all, is two factored forms in a way that allows us to combine. Now, this process right here is harder than the one Sydney did. If you have the ability to combine like terms, always do it. But I'm introducing you the idea of factoring by grouping. So when we get to the next one, the more difficult stuff like we'll see in lesson 14, it actually kind of has some consistency to where we've been. The very last thing that we can see here is the reverse of the distributive property, and that's the following. Does anyone notice anything about my parentheses here? Looking only at that. Anyone notice anything about the parentheses? They're the same, exactly. So when you factor by grouping and you come to the conclusion that Francis just did, that you have factors, parentheses, because these things are factors, they're being multiplied by 6 and 2 respectively. When you have common factors, here's what you can do. You can combine them. Is that right? Since our parentheses are the same, really what's happening here is I'm focusing all of my attention now on combining the things that aren't the same. And since they actually are both numbers, we can add them. So voila. Since we had the same parentheses, we could combine the 6 and the 2, the things on the outside of the parentheses, and 6 plus 2, sure enough, is 8. And 8 times x plus 2, by the way, is the same solution that Sydney gave us by combining like terms and finding common factors. The idea of factoring by grouping is more advanced, but it allows us to break apart bigger expressions and focus on smaller things, so that way we can more efficiently use it. All right, I'm going to pause it there for 1 second, because that's really where we're trending today. And next Thursday, because this is, again, kind of one of the Mondo lessons of the entire year. To answer the question, homework real quick. I don't have it memorized, but I can pop over to it real quick. On the remote learning agenda is 556 to 565. I don't know where I got 556. Sorry, 565 to 567. Numbers 1, 2, 6, 8, 12, 13, and 18b. Okay, so again, check it out on either the remote learning agenda. Voila. Okay, remember it's 4:23 today, so lesson 14, successfully to the right, or on the homework, the assignment sheet that's also posted on every single assignment you can find today's lesson, lesson 14, on the Google Classroom as well. All right, cool. So now here comes basically what we're actually going to start doing. All right, now we want to factor this. So I'm going to start us off with a question, and that question is, what's the GCF? Notice now I have a trinomial, 3 terms. Term 1, x squared. Whoop. Term 2, 6x, and term 3, 5. This is a quadratic power of 2, and it's written in the order of highest power down to lowest power, power of 1, no power because no x. And it has that idea of quadratics that we saw in our Edpuzzle, A, B, C. Okay, so this is a trinomial, 3 terms, which is an odd number of terms. Does anyone see anything that's common, not amongst 2 of them, but amongst all 3? What's the GCF amongst these 3 terms? You can give me a number, you can give me a variable, or you can give me nothing. Oh, Andrew, intelligent answer. You got 1. You're right. The only thing that you could take out of all 3 of these terms is 1. But I'm going to pose the question now. So Andrew says the GCF is 1. He's right. But if your only GCF is 1, is it going to change anything? If I take a 1 out of everything, what's x squared divided by 1? X squared. What's 6x divided by 1? 6x. And what's 5 divided by 1? 5. So really, when we factor out a GCF of 1, we actually haven't done anything. We've just done extra work for no reason because we didn't change anything. We didn't actually change the trinomial. It's still there. So here's the issue. When we have something that only has a GCF of 1, it seems unfactorable, and it might be, but I'm actually going to claim that this one is not unfactorable. Okay, and the way that we're going to learn how to factor this is what we talked about on the vocab, and I'm just going to switch back to it real quick by using what page 5 would call the X method. Okay, The x method. And it's not called the x method because it involves an x variable, and this one obviously does involve the x variable, but it's called the x method because it involves a table that we're going to set up with the x. So let me make a big old X here on the right. So we have no good GCF. So I'm going to resort to the X method. Before I start to resort with the X method, I'm going to ask you a second question. Can I evenly group terms? And notice the keyword is evenly, meaning I have to have the same number of terms in each group. Flash back to the last problem that we did. I made two groups of two. Oh, sorry about that. Two groups of two. Ready? One group of two terms, a second group of two terms. Can I do that with this trinomial? No, I can't. And the reason why I can't is because I have an odd number of terms, okay? So like, for example, if you've ever played sports, let's say you and two friends, okay? And you were playing, I played basketball, so I'll just go anecdotally from my life. If I was with me and two buddies and I wanted to make even teams, I'm not talking about skill level, I'm talking about number wise. I couldn't do it because it would either be 2 versus 1 in some capacity, like one person versus two other people. So you can't make even teams or even groups when you have an odd number of terms. It makes sense. Odd is not even. So the issue here is that we have a expression that doesn't have a GCF, and we can't even use the second more advanced tactic of grouping. So we're going to have to manipulate or change this blue expression so we can group it. And that's where the X tactic comes into play. So no GCF, darn. No even groupability, darn. We got to make it even group capable. So here's how we do so. Ready? I like to call it the Oreo or the sandwich method that allows us to populate the X method, but here's how I view the X method. The X has 4 parts. It has a top, let's use different colors. It has a bottom, okay? And then obviously it has a left and a right side. Cool. So I'm going to fill out the top by doing multiplication. I'm going to take the number in front times the number in back. What is the number? What is the first number, the leading coefficient or the value? We think about it like such. A, B, C. What's the very first number in front of my polynomial? It's 1. So I take the number in front, 1, times the number at the end, 5. Again, this is going to be very step-oriented, all right? First step. Multiply the first number to the last number. Okay, again, this is where putting it in descending order that we talked about last week is super important. I take the first number, descending order, highest power, the number in front's 1, times the last number, the y-intercept, the regular number, 5. Right there, boom. What's 1 times 5? 5. Cool. Top of my X, complete. Second step, step number 2. Bring down the middle number. Okay. Well, 1 my first number and 5 my last number. What's my middle number? C. I mean, sorry, 6, not C. 6. So I'm going to bring it down, and I'm going to bring it down to right there. Okay, again, I'm calling this, I like to call it the sandwich or the Oreo method because it's really quite easy when you sandwich. You have bread on the outsides and all that filling in the middle. In an Oreo, you got the cookies on the outside, cookie, you got the filling in the middle. So that's what we're doing here in the X method. We did the first times the last here, the first number 1 times the last number 5, which gave us that, and we populated the bottom with the middle number 6. Now, the last step about to happen is step number 3. And the best way that I can kind of say that is find the factors of the top, or 5. Find the factors of the top of our X, 5. add up to the bottom, 6. Okay, step number 3, find the factors of the top 5 that add up to the bottom 6. So here we go. Let's think of factors of 5. 5 is a really nice and easy number to factor because it's prime. So what are the only factors of 5? Well, if it's prime, it's got to be 5 and 1. Now, did this succeed in step number 3? Did I find factors of 5? Check. Do my factors of 5 add up to my middle number 6? No doubt. Okay, it's not always going to be this easy. Started off with like a really easy one up front, but here's what we now do is we then, and I'm going to move this way down here. Okay. Now what we do is I'm going to copy and paste this X chart right here, and I'm going to fill in those factors. And what were those factors of 5 that added up to 6? 5 and 1. Let me write this in a little bit darker color here, green. 5 and 1. And I'm going to now drop those numbers in on the sides. Again, this is, as I mentioned from the jump today, today's lesson is probably one of the hardest in all of Algebra 1. So it's a lot of steps, which is why I put these notes up, by the way. The notes that are up on the PowerPoint, they walk us through this step by step, okay? 100% walk us through this step by step. Right. Okay. Walks us through how we could find factors. Is we have taken something that was a trinomial, something that wasn't perfect, something that was hard to factor, x squared plus 6x plus 5, and what we've now done with these middle numbers, 5 and 1, the Oreo, so to speak, is we have given ourselves the ability to expand this middle term 6x into 5x and 1x. Now, where did I get this 5 and the 1 from? 5x and 1x. Where did I get those from? Boom, right there. So the whole of this tactic, all those steps, multiplying first times last. One number, one to the top. Bringing down the middle. Boom, right there. And then finding the factors that add up to the middle is basically to do the following. To be able to expand this 6x into 2 other terms. Now, it seems like it is lengthy when we first learn it. As we get more practice, like anything, it becomes really second nature, but we're not there yet. The whole point of this was to now allow us to say, oh, boom, let's factor by grouping. Okay. We have taken something that was 3 terms, odd, can't make even groups, and we expanded the middle term into 2 terms. Why? So we had one term, 2 terms, 3 terms, 4 terms, and now we can factor by grouping. Let's look at each group individually. What can I take out of my first parentheses? What's the GCF? Anyone think they know what I could take out of both x squared and 5x? Is there anything that both of those terms have in common? I like 1, but there's actually something else that we could take out other than just the number 1. Great call, Ava. I appreciate the answer. Like, let's actually like legitimately zoom in and see like what do you notice that both of those actually have? Yeah, Ava and Sarah combined with the clutch assist here of x. You can take an x out of both of them. Look at because this one legitimately has an x being squared, and that one has an x right next to the 5. So if we take x out, here's what's really happening. Let me kind of do the work beneath it. X squared is x times x. 5x is 5 times x. If we take an x out of both, well, then all we have left is x squared divided by x. X squared, taking out one of those x's, is just x. And if you take the x out of 5x, you get just a regular positive 5. Sweet. Okay, nice. What can we take out of my second group? What can you take out of both an 1x and a 5? And this one I'm going to answer here. What can I take out of both a 1x and a 5? Well, notice both of these things don't have an x. This one's the only one that has an x. That one's just a 5. Recall, Francis, we could take a 1 out of both. So I'm going to stick with purple here. That's my GCF of 1. What is anything divided by 1 itself? So what we have now is just a regular 1x, which I'm just going to write as x. And what is 5 divided by 1? Still just 5. Okay. Now, actually, I'm gonna call Sarah plus 5. So now I'm gonna call on Francis, because you were the expert that noticed it the first time. What do you notice about our parentheses at this point? And it doesn't just have to be Francis. If you all notice this, or shout it out if you have your mic, if you're unmiked, if you want to exactly do the same. Tyler, Francis led us to that realization up here before we went through this crazy thing. He said, all right, look at those parentheses are the same, so we combined them. And that's the same logic down here now. Since these are both, as Tyler said, since these are both the same thing, x plus 5 and x plus 5, these two parentheses, well, really what's going on here is I can combine the GCFs. Since both x is being multiplied by x plus 5 and 1 is being multiplied by x plus 5, I can combine the two, x plus 1, and that's just the distributive property in a weird way, kind of a hidden way. Exactly, Sarah, they're both the same, so we can combine the two and multiply them by, boom, the very same parentheses. Now, what we've just done, everyone, is we have just factored that polynomial. And here's a quick check. Ready? Let's turn it around. X plus 1 times x plus 5. Last week, we were empowered with the skill of foiling or distribution. So if we were to go about distributing, here we go. X times x is x squared. X times 5 is 5x. 1 times x is 1x, and 1 times 5 is 5. So if we turn right back around and we did the multiplication that's inherent in these factors, because factors are multiples, what we would get to be right here, we would combine like terms. 5x plus 1x is 6x. We'd bring down the things that aren't like terms and take a look at what we have here, and let's relate it to where we started. Okay. They are the same. What we just learned how to do, everyone, was we learned how to take a polynomial, circled in orange, break apart the middle term, because it's 3 right now, can't group it. Break it apart into 2 other numbers that add up to the products of the first and last. Use grouping to factor out GCFs of each group. And then once the parentheses were the same, which is our huge goal, combine them, boom. What I'm actually about to box in black is the factored form. That is the answer. Okay, that is where we're trending. And the whole reason we're trending to this is to make solving for second power equations that look super hard and do take work a little bit more understandable with the zero product property that we learned on Tuesday. Now, we're going to do one more example, and that's pretty much where we're going to end off class today, okay? Here's our example. 1, do we have a GCF? No. Can't take something out of all 3 terms. 2, can I factor by grouping? No. Odd number of terms, 3 of them. I'm not saying 3 because of that number 3, but because we have 1, 2, 3 terms, and none of them are like. So we can't add like terms. You can't take anything other than 1 out of it. So what I'm going to do is I'm going to use my X tactic. Let's go. Step 1. Find the product of the first number and the last number. So what's the number that I have out front here? What's the number in front of x squared? 1. So first times last, 1 times 3 is 3. Step 2, take the middle term and bring it on down. What's my middle term? -4. Step 3, find the factors of +3 that are going to add up to -4. Does anyone know the factors of +3 that add up to -4? Because those are going to go on the sides. Here's my question, y'all. Step 1, first times last, top of the x. Step 2, middle, bottom of the x. Now I want to find the factors of 3 that add up to -4. That's what I'm trying to do right over here. Can you think of the factors of +3? Boom, Andrew, let's go. Nice. A negative times a negative makes a positive. And sure enough, -1 plus -3 gets into -4. Nice, man. That was a tricky one. I got a little bit harder on this, but -1 times -3 makes that +3, and they add up to -4. What Andrew just did is he has now given us the ability to rewrite this problem. I don't like this. Boo. So what Andrew just did is he gave us this ability. He said, all right, let's take that -4x and let's separate it into 2 other terms. And those 2 other terms happen to be -1x and -3x. Sure enough, legitimately, if we were to focus only on this and we were to combine like terms, we'd get right back to where we started. But what we're now trying to do is execute grouping. So let's group them up. Ready? Group. Group. Whoa, sorry. Group. Now, why do we want to group? So we could use GCFs. GCFs of each group. What can I take out of my first group? What do they both have? X. Great call, Francis. So I take an x out of both. Ready? If you have an x squared, and I have one here, x squared is the same thing as x times x. So if I take one of the x's out, what am I just left with? A single x. If you take an x out of -1x, what do I have left? Just -1. Money. Okay, we're cruising. We're making progress. What can I take out of both of these things? This one's tricky because keep in mind, here's the heads up, y'all. Once we know what our parenthesis is, at the end, we have to have the same parenthesis. So here's what I always do. In this process, I just copy and paste that parenthesis right there, and it allows me to see the GCF. Because Sarah, you're right. We could take a 3 out of both, but if we get a 3 out, we have -x plus 1, and that's not the same thing here. So my question, I guess, now is, what do I have to take out of? What do I have to take out of -3x to leave just the x? And what do I have to take out of +3 to make it a -1? What do I have to take out of -3? Yeah, good call, Francis. To make -3x finish off with just an x, I got to take out that -3. And sure enough, what happens when we take this +3 right here and divide it by -3? We get, boom, -1. So our GCF in this case could have been 3, but it's more efficiently what Sarah, Francis, and Andrew have just written there, -3. Because guess what? Now what do we do since we have common parentheses? We combine the GCFs, x and -3, which is just x minus 3. So combine them. Since we have common parentheses, we combine our GCFs, and they stick with the parentheses as they were. Factor. Last thing that we have to do is just check it. I'm going to do that rapid fire right now. Ready? Just by using our skill that we got last week, x minus 3 times x minus 1. X times x is x squared. X times -1 is -x. -3 times x is -3x. And -3 times -1 is +4. We combine like terms. I wrote 4 over here. My bad. It should have been 3. Can't do my multiplication. And let's check to see if that distributed form matches what we were trying to factor in the start. It does. Success. And that's going to be wrapping up our lesson for today. So on that note, I cannot stress enough how much I appreciate y'all being here. This is a very tough lesson to kind of work through. If we understand this, the remainder of this class is going to be relatively smooth. And also Algebra 2, you'll cruise it, okay? So we're going to continue to work through this next Tuesday. This is like legitimately the lesson that we're going to stick on, and maybe even all of next week. I'm going to kind of play it by ear depending on how we feel as a class. Please come tomorrow at 10 a.m., excuse me, if you want more work on this. If not, I'll see you next Tuesday. Please be safe, stay healthy, and have a great rest of your day and weekend, y'all. Stick around if you want to ask questions. If not, I'll see you then.